Here's some homework from Unit 5, Lesson 14. You'll see some things that are pretty similar to what we did in class. And the first thing that's here, complete the table with all the missing information about 3 different cylinders. What I would really prefer that you did is this: create and fill out in the table using the table button. Click that table right there. Looks like it's not going to work while I'm recording, but what'll happen is it'll open up a new table for you to fill out and copy this one here. Likewise, you could just take a copy of this, screen capture, and then fill it in. But what we're after with this is we're looking at completing the table with all the information that's missing about the 3 cylinders. Take a look at what we have. Remember that we're talking about the volume of a cylinder. Volume is equal to the ratio of pi times the radius squared. That's the area of our circle, or the area of the base, in this case right here, times the height. And so we need to look at what pieces of information do we have, what are we missing, what do we need to solve for. When we think about this, look at what I'm looking for. I have the diameter, I have the area, the height, and the volume. Diameter isn't going to help me a whole lot, so I'm going to look at this and say that I want the radius, because that's what fits in. This will be a radius of 2, a radius of 6, not 6, sorry, a radius of 3. So half the diameter. And then I can start finding things out. I have the height, I have the radius for the first one, so I need to find volume. Volume is equal to pi times the radius, 2 squared, times the height of 10. And then I can find the volume for that. And when we look at this, what I would really like to see is I would like to see it in terms of pi, because of the way that this is all written out. The second one, what do we not have? We don't know the height, so we do know the volume. 63 times pi is equal to the ratio of pi times the radius. Oops, sorry, I don't want R for that one. I want 3 for that one. Squared times height, which means I need to find height. You can take a look at the lesson video and you'll see with these pieces exactly how to do this. But the idea is that we want to use properties of equality to simplify or to solve for our unknown variable. So I'm going to leave you to the last one again. Substitution is the key thing, and then solving using properties of equality. Do not answer in anything but in terms of pi. I don't want an approximation of 3 1400ths. When you're done with that, you're going to submit your answer right inside here. If we have a cylinder that has a volume of 45 times pi and a radius of 3, what is the height? Again, we're looking at the same thing. Substitution. Volume is equal to pi times the radius squared times the height. Take a look at what we know. I know the volume, so I can replace 45 times pi. I can replace radius with 3, and then all I have to figure out is h. Recall that what I can do is I can divide up pi divided by pi is 1. Remember, in your answer, give your answer in this form. If it's a value that's going to repeat or do anything like that, then we need to give it as a fraction. I don't want repeating decimals in there. If you have to round it, leave it as a fraction. We have 3 cylinders in this next one. They have a volume of 2,826 centimeters cubed. Cylinder A has a height of 900 centimeters. B has a height of 225 centimeters. And C has a height of 100 centimeters. In this case, we are going to use 3 1400ths as an approximation for pi. Do not include the centimeters in your answer. It's really important that we read directions for this one. And then your job right here is to just find the radius for cylinder A. All of these cylinders, right, the volume of each cylinder is the exact same. So cylinder A has a total volume of 2,826 cubic centimeters. Cylinder B has a volume of the exact same. So the volume is not changing. What's happening is just the height is changing, which means that our radius, our diameter, has to be changing with it. So the shorter that we go, the larger the radius has to be. So again, it's the same type of thing. Substitution, we have volume is equal to pi times the radius squared times the height, and we look at what we're given. In this case, we are given the radius of cylinder A, the volume is 2,826. The radius is unknown. Pi is going to be approximated to 3 14/100. We're trying to figure out the radius, and the height is 900 centimeters. So with that, do a little bit of simplifying, do a little bit of solving, and we should be able to find out what R is. I will help you with this one a little bit more though, because I think that there's a little bit that we can learn about it. We need to simplify the right side. 3 14/100 times 900 is going to be 2,826 times R squared. That seems a little interesting because when we do that one, they come out almost exactly the same. So what does that mean about the radius? Well, that means that the radius must be equal to 1. For the reason of this, if I divide I get 1 is equal to the radius squared, and the square root of 1 is 1. Okay, cool. There's our radius. But this is the same kind of work that we're going to do with each of the rest of them for B and C. The end piece of this is if we have a squared value, we have to take the square root to be able to justify what that value is. Okay, so you've got B and C in that one. We're going to skip this next one about the gas company and go to a little bit of review. Here's a graph that shows the water height of the ocean between September 22nd and September 24th, 2016 in Bodega Bay, California. We can see the water height is the y-axis, the date and time is the x-axis, and we're supposed to estimate the water height at 12 p.m. on September 22nd. So when we look at these, be really careful that we're looking at the AM and PM, and we're looking for September 2nd, so we're estimating the water height at that moment, okay? Do not include feet in your answer. You need to come up with a really, really reasonable response for that one. Put it in there. How many times was the water height above, or the water height 5 feet? So right at 5 feet. We want to look at that. Imagine drawing a horizontal line through 5 feet all the way across and finding out how many times did we have that value. Part C, find a time when the water height was at 5 feet on 9/22. So we want to just look at this date right here, and we want to find out when was the water height at 5 feet. Sorry, this date, 9/22, is those two. Oh, hey, cool. I learned something new just now. At what time was it 5 feet? And then part D, find a time when the water height was at 5 feet on the 23rd. What was the lowest the water got during this time period? What was the lowest, or when? Sorry, what was the lowest the water got? So find out how much water there was in part E. When was the water at its lowest? And does the water ever reach a height of 6 feet? This problem is really just reading the graph. So let me know if you have any questions about it. Have yourself a great day.